Hello everybody, my name is Kyglo Webb and welcome back to another episode of Spicy Coding Academy, where I will be walking you through some tutorials on FreeCodeCamp. And if you are enjoying these videos, I highly recommend signing up for our cohort February 20th, where we will not only teach you how to code, but we will make it fun with trivia, games, community, a Discord group, and much more. Some of these games, some of these stories are very interesting, but for the meantime, let's do some of FreeCodeCamp's straight to the point tutorials. And we left off at returning Boolean values from functions, and we will go all the way down to accessing object properties with variables. So let's get started. So for this one, you may recall the comparison with the equality operator, that all comparison operators return a Boolean true or false. So whenever you have a comparison operator, something that is doing a comparison, it will automatically return true or false. You don't need to write this. It is unnecessary. So essentially it wants us to take this and take out the unnecessary, take out the redundant, and make it beautiful, happy, peaceful, and your other coding programmer friends very grateful that they don't have to deal with all these brackets and all this mumbo jumbo that is unnecessary. So if we go over here, it says, hey, some people use this. If A is equal to B, strict operator, return true, else return false. And they're saying, hey, you don't have to do all that. All you have to do is return A equals B. And if it doesn't equal it, if it's not true, it'll just hop out of the function. So let's go over here. Let's use our deductive reasoning and think for a second, what do you think should be removed? Knowing that if we ever use operators, it automatically will tell us true and false, so we don't need to say return true or false. What are all the things that we don't need? Now, if you guess the if statement, that is correct. If you guess the return true statement, that is also correct. If you guess the return false statement, that is also correct. If you guess the else statement, that is also correct. Now all we have to do is take that return, put it in front, and then voila. We also don't need that. And then look at how clean and precise and nice this is. It takes away so much unnecessary lines of code, and we can just condense it. So then when we pass in 10 into the A parameter and 15 into the B parameter, it can automatically test true or false just with one statement. Is 10 less than 15? It will be true. Boom. And if you want to also check down here, is less 10 than 15 should return true, and it does. It's 15 less than 10, it returns false. No if or else statements. All right, next one is when a return statement is reached, the execution of the current function stops and control returns to the calling location. So the above will display the string hello, because it doesn't console.log, which outputs it on the screen, and return the string world. The string bye-bye, because it also does return world at the end, which also, boom. But because the function exits at the return statement, the string bye-bye will never display. So the return is when you want to end a function. This is leaving it. So anything you put before the return will be printed out. Anything you put after the return will be left out, because once you output the return, it just pops out. It hops out, says, okay, I'm done with the function, my fun. I'm hopping out. I do not need to do any more work. So that's why you got to be smarter than the computer and put this sucker before the return statement. So now it says modify the function abtest right here with two parameters, a, b, so that if a or b are less than 0, the function will immediately exit with a value of undefined. So A or B is less than 0. I'm going to give you a quick second to think about this. So remember, we got an interesting or. If you remember from our past tutorials that we went over, or is equivalent to pixie sticks. So it wants us to see if A or B are less than 0. How are we going to do this? Remember that undefined is a keyword, not a string. So a keyword is something like this. A string is something like this. A string can also be something like this. And a delimited string can be something like this. And this is a cool one because it's multiple lines. You can do it like this. And you can also do interpolation, which we will talk about in the future. So keyword is something like return, something like true, something like false. So undefined is included in those. So knowing that, going back up here, it wants us to modify it so that if A or B are less than 0, the function will immediately exit with the value of undefined. So then if we do if A is less than 0, and then pixie sticks, B is less than 0, what are we going to do? Return the keyword undefined. Let's see if it works. Boom. And if you want to see also and check all the conditions it ran, ab22 should return a number. ab22 should return 8. ab-22 should return undefined because -2 is less than 0. ab2 and -2 should return undefined. So all it needs is one of these conditions to be true in order for it to return undefined. If we had ampersand, then it needs both of these to be true in order for it to return undefined, and this would no longer work. We would fail the test. So pixie stick it just needs one in order to be undefined. All right, the next one. Counting cards. So in the casino game blackjack, a player can determine whether they have an advantage on the next hand over the house by keeping track of the relative number of high and low cards remaining in the deck. This is called card counting. Having more high cards remaining in the deck favors the player. Each card is assigned a value according to the table below. When the count is positive, the player should bet high. When the count is 0 or negative, the player should bet low. And when it's saying bet, it's talking about money. So essentially, to make this as simple as possible, blackjack, you want to try to get to 21 before the house does. You want to try to get higher, as close as you possibly can to 21, more so than the house, and then you win the bet, or versus other players. So you got to be aware of the cards that you're counting. And this is a function that will help us be aware of the cards and when to bet or when to hold. So essentially we're like, hey, I want to create a function to keep track of my numbers so that I can know when to bet and hold, because I want the computer to do the thinking and I want to listen. So that's for anyone who wants the computer to do work. We create a function that causes a certain behavior, a certain action to do on our behalf. So it says you will write a card counting function. It will receive a card parameter. Here's your card parameter, which can be a number or a string. See, a number or a string. And increment or decrement the global count variable. Here's the global count variable because it's outside of the function. According to the card's value. Here are the card's values. The function will then return a string with the current count and the string bet. So remember how to connect things in a return statement? I'll give you a hint. Concatenation. Okay. The function will now return a string with the current count and the string bet. If the count is positive or hold, if the count is 0 or negative. The current count and the player's decision bet or hold should be separated by a single space. So essentially, if you're getting one of these, hold. These are big cards. If you're getting one of these, bet. Now, this isn't always going to work out because realistically, in the game of blackjack, you're not sure what kind of card you're going to get next. So, if you're already close up to the top and you're like, hey, I don't want to risk it anymore. Let's say you have a total, your cards add up to 15. You're like, hey, I'm going to hold. I'm not going to bet anymore. You could just roll with that. But realistically, you don't want to keep on asking. These are risky already. You could lose it. So we're trying to create a function that is applicable, but also realistically, it's better to just computationally do this yourself. So anyways, we're going to go back over here and we're going to write it. So let count equals 0. So if the card is less than or equal to 6, we're going to increment count by 1. If it's 0, we're not going to do anything. If it's -1, or if it's greater than or equal to 10, or the card equals a string, J, Q, K, A, those are all strings, we are going to decrement count by 1. So we're going to go over here, get rid of this because it's in the way. And we're going to start with an if statement. If the card is less than or equal to 6, because we want to go less than or equal to 6, we're going to increment the card count to count plus plus. That's going to change it by 1. And then else if the card is greater than or equal to 10, this one right here, and also the reason why we're using a string is because it can typecast with just one equal sign. If it's a strict operator, it wouldn't be able to typecast, but with one, we can typecast. And then we want our pixie sticks because we also want to include the ability for it to grab these strings, which essentially it's string, but we're just making it a little more specific here by doing a or. And we're going to do card equals, let's actually do it like this. Okay. Then what are we going to do? We're going to count minus minus. So essentially we want it to catch the strings. So type of card, if it's a string, then we want it to catch it and decrement it. So type of is hard-coded into JavaScript to be able to tell if that card is a string. And then we're going to decrement it. And then at the end, instead of return change me, we're going to change it to that concatenation. And I'm going to show you a new thing to make this easier. This is the concatenation because we want to say what count is, but then we also want to go over here and say if we should bet or hold. So if count is less than 0, we're going to do essentially an if-else statement, but we're going to make it even shorter. So this is saying, essentially, it's a short way to say if-else. If it's true, we're going to go here, we're going to do a little tick mark, space, bet. But if it's not true, we're going to do tick mark, space, hold. So if it's less, you're going to hold. If it's more, then bet. So it's like, if it's true, bet. If it's not true, if it's false, hold. So this just makes the if-else statement even shorter. Just imagine this is going to represent if-else but it's going to put it on one line to make it super easy, super quick, super fresh. Now let's check. Boom. So just to recap, if card is less than or equal to 6, we're going to increment count, the global variable, count plus plus. Else if card equals 10, or, so either or can be true. So one can be true for it to do count, to decrement count, the global variable. And then we're going to check the type of the card to see if it's a string. If it's a string, then that means also decrement. And then we're going to return count. We want that number because it wants us to output the number on the left side, and also wants a space. So that's why we have that space right there, is we put it literally here because it's going to output. It's going to return bet, or it's going to return hold. And it's like an if-else statement. So it's count greater than 0. If it's true, return space plus bet. If it's false, return space and hold on the right side of this count. So hopefully that makes sense. And here you can check the conditions. So 2, 3, 4, 5, 6, return the string 5 bet. And if you look at that, put it through, so shall it be. Build JavaScript objects. So this is super easy, guys. This is just easy peasy lemon squeezy. JavaScript is a very flexible language. You'll learn that really quickly. Objects are similar to arrays, except instead of using indexes to access and modify their data, you access the data in objects through what are called properties. Objects are useful for storing data in a structured way and can represent real world objects like a cat. What about a dog? What about a bird? It's limitless. You can choose any object you want. Here's a sample cat object. So this is the object. And in this example, all the properties are stored as strings, such as name, legs, tails. So these are all properties. On the left side, imagine properties. You can imagine a properties. Kind of reminds me of proper ladies, proper ties. You can imagine ties as being super proper and eating properly and looking properly. That's on the left side. On the right side can be strings, or it can be numbers, and it can even be arrays. So for single word string properties, you could just put a 5. However, if your object has any non-string properties, JavaScript will automatically typecast them as strings. So might as well just, make them string if you want or not. But regardless, I like to make them all the same because it just looks a little neater. So make an object that represents a dog called my dog, which contains the properties name, legs, tails, and friends. So let's start one at a time. So we got const my dog. This is our object, my dog. We want to put in the properties. So we're going to start out with string. It says with the name property. Okay, so which is going to be a string. Let's name the dog Bob. Don't forget that comma. Go down here. Legs. Now legs is going to be a number. So because it's a number, you're not going to have these parentheses. So it's just going to be 4. Or if Bob has 5 legs, 6 legs, who knows? Bob could have many legs. Bob could be like a spider dog. Who knows? Then for friends, it wants an array. Legs and tails are numbers. So Bob has 2 tails. Don't discriminate. Bob has 2 tails. That's just how he was born. That's how he's gonna die. 2 tails. Now we're gonna do the array at the very end. Does Bob have friends? Yes. Pete. And see how there's a comma in between here? And there's no comma at the very end? Pete and David are Bob's only friends. Bob doesn't really get out that much. But Bob does live a good life with 2 tails. Boom. Look at that. We did it. Now, accessing object properties with a dot notation. There are 2 ways to access the properties of an object. Dot notation and bracket notation, similar to an array. Dot notation is what you use when you know the name of the property you're trying to access ahead of time. So, val1, val2, these are the properties, these are the values. This is the object. So when it says const prop1 val, it's saying, hey, I'm going to store it in this variable. I'm going to call the object because we want to say what object we're calling, and I'm going to call the property so that I can get the value. And it's going to do that for const prop2 val. It's going to store it into this variable that we just created. Equal sign mean, hey, I'm going to store it in here. I'm going to call my object. I'm going to say what property I want so that I can see the value that I want. So it says, read in the property values of test object. This is our object using dot notation. So the same thing up here. Set the variable hat value equal to the object's property hat, and set the variable shirt value equal to the object's property shirt. So here is the property hat. This is the value that we want. So we're going to call the object right here. Then we're going to do dot notation. And what do we want? We want to put the property. The property is on the left side. Property. Remember that. And then we want for test object, we're gonna store this hat into a new variable called const hat value. And this will not change because it is const. We're going to do the same thing. We're going to call the property test object shirt value. We're going to call shirt. And it's going to give us jersey. Jersey will be stored in the const shirt value, and ball cap will be stored in the const hat value. Easy peasy, lemon squeezy. Look at that. Boom. Accessing object properties with bracket notation. Okay, this will actually be our last one because this video is getting longer than expected. Second way that properties of an object is bracket notation. So you're trying to access has a space in its name, you will need to use bracket notation. So say you make your property with a space, you're going to have to resort to this. So it's just easier to make it no space. But anyways, going down here, we have our object, const my object, properties on the left, values on the right. And it says my object space name would be the string Kirk. My object more space would be Spock. My object no space would be USS Enterprise. So it says read the values of the properties and entra and the drunk of test object using bracket notation and assign them to entra value and drunk value respectively. So we go here. We know we're not going to change that line. Don't worry. We know and we know. Okay. So now it says read the values using bracket notation. And would you look at that? Test obj, here it is right here. And we are saying, okay, now we're going to use the array because there's a space in between here. We can't use the dot one because there's a space. We're going to put the property right here, which will give us the value hamburger stored in entra value. So then whenever we call entra value, we will get the value hamburger. So this variable stores this value. In order to get it, we want to find the object that we're working with, put the property on it on the end. If there's a space, use these brackets, and then const string value will store the value. Sorry, I keep on saying const string value. It'd be better if they said variable because that's what it is. We'll store, boom, water will be the value. But that's just what they chose, which is a little confusing. But this is a variable right here. This is a variable. You can choose for it to be whatever you want. This is a value. This is a property. This is an object. Boom. All right, everybody. That's the last we have for today. I hope you enjoyed it. And if you